So students, welcome to another session of composite materials. Today we will see the classification of different composite materials. So constituents of the composite materials, it can be classified into basic three types: particle reinforced, fiber reinforced, and structural composite. In particle reinforced, there will be large particle or dispersion strength or fine particle. In fiber reinforced, these are continuously in nature or discontinuous in nature. Similarly, discontinuous in nature, discontinuous composites can be again classified into aligned composite as well as randomly oriented composite. The structural composite can be classified into laminate composite as well as sandwich panel or sandwich composite. These are some examples of randomly oriented, continuously oriented or discontinuous, which are randomly oriented, large fine particle, large particle. These are continuously aligned in nature. This is example of laminate composite. So based upon reinforcement, particle composite, particle reinforced composite, fiber reinforced composite, and structural composite. Similarly, based upon the types of matrix we used, the composite can be classified as metal matrix composite, ceramic matrix composite, and polymer matrix composite. So you see, again, based upon the concentration also composites can be classified. Similarly, based upon size, short fiber, long fiber, based upon orientation, randomly oriented or this continuous in nature, based upon shape, different shape, based upon distribution. So all these characteristics can be, based upon these characteristics, composites can be classified into different. As I said, the matrix phase is soft and flexible and continuous, whereas reinforcement phase is hard, stiff, and discontinuous in nature. Reinforcement material, that's why as a result of this, reinforced composite can be classified into based upon their shape and orientation. You see, this is an example of particulate composite, long fiber composite, short fiber composite, laminate composite. Now in short fiber, see, this is an example of randomly oriented composite. If these fibers are continuous in nature, then it will be a dispersion, it will be a short fiber continuous in nature. Fiber, you will see the first one, the fiber reinforced composite. Fiber reinforced composite will provide excellent strength to weight ratio, stiffness, fatigue resistance. So fiber composite, it consists of two phases, fiber as well as matrix. Fiber, there are different types of fiber can be used for the fabrication of composite material. Glass fiber, carbon fiber, ceramic fiber, different organic fiber, metallic fiber, glass fiber or silica based. These are quite cheap and very much provide good excellent property. Carbon fiber is a very light element. Graphite form is considered the carbon fiber. It also exhibit excellent property. Ceramic fiber, commonly aluminum oxide, silicon carbide fibers. These are possibility to use in high temperature application. Organic fiber, as a name example, Kevlar, very high impact resistance. Metallic fiber, wire form of titanium, tungsten, molybdenum. The fiber are responsible for handling the applied load. Types of matrix. So this fiber along with matrix will be called as fiber reinforced composite. So what type of matrix is used in the fiber composites? It can be polymeric material. Polyester resin, commonly used due to low cost. Polyester resin, epoxy resin, vinyl ester resin, metal, similarly superalloys, aluminium, magnesium, titanium, copper and their alloys, ceramic, alumina or aluminum oxide, zirconia, zirconium dioxide. So the matrix must be able to transfer the mechanical load to the fiber. It should be able to protect the individual's fiber from surface damage. It should have adequate adhesive bonding forces between the fiber to minimize the fiber pull out to get ultimate strength of composite. So these are the characteristics of the fiber, so that it should be used in a fiber reinforced composite. Now these are some different types of fiber property. on the density, tensile strength, tensile stiffness, E by rho ratio, S by rho ratio. Classes according to reinforcement and matrix. Metal matrix, whatever the reinforcement can be used. Ceramic matrix, these are the reinforcement can be used. Similarly, glass matrix, glass and ceramic particle. Organic matrix, carbon fiber, glass fiber, organic fiber, these are can be used. So simultaneously it will give you the specific application, specific property. So we'll see the impact of fiber amount and orientation on performance of composite. Most fiber reinforced composite contain 35 to 50% of fiber by volume. When fiber fraction exceeds about more than 80%, exceeds 80% above, there is no enough matrix material to completely surround the fiber and transport the load effectively. Aligned fiber results in the more reinforcement in aligned direction than any other direction. Randomly oriented fibers are isotropic in nature and provide same property in all directions. Fiber property results in a higher strength and ability to withstand loads in multiple directions. These are some examples of discontinuous, still randomly oriented fiber. Discontinuous and aligned, continuous and aligned. Here is a fiber woven structure. Now we will see why we will use fiber reinforced composite material. These are high performance composite material. Soft plus ductile matrix plus strong or plus rigid brittle fiber can achieve improved wear resistance, higher stiffness, better strength to weight relationship. So when you require a application consists of high stiffness and strength with low density, it will be best possible composite material, it will be best suitable material to use FRP material, FRP composite. Now these are some examples, these are the some example of fiber reinforced composite, how intactly the fibers are interlinked with the matrix material. Now types of fiber, glass fiber, these are the example of glass fiber. Continuously aligned, randomly oriented, woven structure for laminate. These woven structure are very much used for laminated structure, laminated composite. Next we will see particulate composite. It cannot provide the same strength as fiber reinforced composite, but it is much easier to manufacture and also economical. So it contains large number of particles that called aggregates that help to withstand the composite in a compressive load, possessing same property in all directions. So you can call this particulate composite can be isotropic in nature. Most common particulate composites are Portland cement concrete, asphalt concrete. These are the example of concrete material, asphalt concrete material. So these are example of particulate composite. Third one is our structural composite. So this is a lamina or sandwich. Normally it's composed of both homogeneous material and composite material, the property of which depends not only the property of the constituent material but also geometrical design of the various structural materials. The way you oriented this direction based upon this one. So multiple layer with different orientation can provide your required dimension or required property. It is an example of then this is an example of sandwich property. So these are face plate will be used, then adhesive, then your honeycomb structure. You will make totally one fabricated your sandwich panel like this. So the core material is lightweight. Core material is typically fall within three categories: rigid polymeric foams, which are examples of phenolics, epoxy, wood and honeycombs. Now next we will see the classification of material composite according to their matrix material. So there are three types of matrix material. Basically three types of matrix material can be used: polymer matrix, metal matrix and ceramic matrix. Polymer matrix, polymer resin is used as the matrix material, where the fibers are the reinforcement medium, can be other things. These materials are widely used in various applications as well as in the largest quantity due to room temperature property. These are easy in fabrication and cost. Glass fiber reinforced composite. This is an example of polymer matrix. Carbon fiber reinforced composite. This is another example of this polymer matrix composite. GFRP and this CFRP. These are very much widely used in automobile and as well as aerospace application. Next one is your metal matrix composite. Polymer matrix composite cannot be used as higher temperature application, whereas this metal matrix composite can be used as applications which consist of higher atmosphere, higher temperature atmosphere. The ductile material is used as matrix, where fiber can be a soft and brittle material which have this written reinforcement material are rigid in nature. It will be used as higher service temperature than their base metal counterparts. Some of the advantages of the material over polymer matrix include higher operating temperature, non-flammability, greater resistance to degradation of organic fluids. Of course, it is much expensive with PMC. So metal matrix is used as an automobile application. This piston, cylinder, brake disc application, all those applications can be used in metal matrix composite. The next third one is our ceramic matrix composite. Ceramic matrices are inherently resilient to oxidation and deterioration at elevated temperature. Some of these materials would be ideal candidates for use in high temperature application. One disadvantage of this ceramic matrix is its brittleness, high brittleness. The ceramic matrix composite consists of high brittleness. And it also consists of fabrication process It consists of with high temperature, so the processability for manufacturing method can be little difficult. Now next one concept is called hybrid composite. So previously what we saw, one matrix plus reinforcement. When multiple one or more reinforcement are used with matrix, it will be called as hybrid composite. So that's for this session. In next session we will see for another new topic of composite material. Thank you.